The second question is, if C is equal to 1 farad, if C is equal to 1 farad and D is equal to 1 centimeter, what would be the area of the plate? We'll solve this question. So we know C is equal to epsilon naught. The formula is C is equal to epsilon naught A by D. Then what will happen? A is equal to what? C into D by epsilon 0. So A is equal to what? C is 1 farad into distance is 10 to the power of minus 2 divided by 8.85 into 10 to the power of minus 12. So that will become what? So into 10 to the power of how much? Plus 12 become plus 10. Plus 10. A 1 by 8.85 will become 1 by, that will become epsilon naught. Yeah. So that will become 1 by 8.85. How much it will be? 1 divided by 8.85. 0.112. 0.112. It will become approximately 111.2 into 10 to the power of 8 square meter. You know, if you want to hold a charge, if you want to charge 1 farad, then you need this much of area of the plate. The area of the plate should be this much, means it is equal to a island. It's equal to island. One plate is equal to island. That much big should be the size of the plate. If you really want to store 1 farad, one capacity of the farad, you want to make a capacity of like 1 farad, then the size of the plate should be equal to island, 10 to the power of 8. That much big, you know, that much big is required. Plate is required. Maybe you know, Kish Island, that much big island you need to store that one farad capacitance. So that is why generally we have in microfarad, millifarad, nanofarad, picofarad, like that. Okay, we don't have farads. Okay. Now, is it clear, all of you? Next one is I am going.
Yes, sir.
So one should have an idea of farad. Okay, don't think just farad, just write farad in it. Okay, whether it is milli, micro, nano, that you have to write properly. Otherwise, the meaning will change. Now, we have, suppose the capacity, the electric field. Again, see, with the dielectric medium. Okay, introduction of dielectric medium. We are going to introduce a dielectric medium between the 2 plates of the capacitor. Okay, between the 2 plates of the capacitor, we are going to introduce a dielectric medium. Okay, this one. Now, so what will happen here? So E0 is equal to sigma by, we have E0 is equal to sigma by epsilon 0. Okay, this is with air medium. This is with the air medium. Second step is what? V0 is equal to E0 by D. Third step is what? C0 is equal to Q by V. Okay, so Q by V0. This is Q by V0, which is also equal to what? Epsilon naught A by D. This is with the air medium. Okay, this complete is with the air medium. Now I want to go with the dielectric medium. In dielectric medium, what will happen? When you see carefully, this is the positive plate. I'll just draw it a little bigger so that you will understand. So this is the dielectric medium like this. So what happens if this is positive? What will happen? This will become the whole thing negative. You know, dielectric medium, what will happen when you place a dielectric medium between the 2 plates of the capacitor? It's like it is interfering the electric field, is it not? There is an electric field from positive to negative. There is an electric field from positive to negative, but this fellow is interfering that because of the dipole moment in dielectric substances or in dielectric material, there is a dipole. So what happens to the dipole here? All the dipoles will be aligned in the direction of the field like this, positive, negative, like this. Okay. Suppose if this is the electric field, all the dipoles will be arranged in the electric field. Clear? Like this, plus minus. All the dipoles will be arranged in the electric field. So we have C0 is equal to epsilon naught A by B. So next we have surface charge density. Okay, we have surface charge density. That is what? Minus sigma P and then sigma P. Minus sigma P and oh, hero is back. How are you, man?
I'm fine, sir. How are you, sir?
Good, sir. Only I think 13-14 minutes are left.
Yeah, sir. Sorry, I forgot.
No, you slept, I think. Huh?
No, sir. I was doing maths. I have a test tomorrow.
Okay, net surface charge density. Net surface charge density. Surface charge density. How much it will be? Suppose this is interfering now. This electric field, this dielectric material is interfering the electric field. So in that case, what will happen? Actual was sigma. Actually, before there was like, when it was like this, only the positive plate and negative plate. So what happened? There was only sigma. There was electric field directly. That is sigma. And this is sigma P. Is that clear? That is due to the polarized. Sigma P is for polarized. So we need to subtract them. So what will happen now? Net will be what? Plus or minus sigma minus sigma P. Okay. Plus or minus sigma P. So what will happen? Now again I have to start from the beginning. Electric field with the dielectric medium. E is equal to what? Sigma minus sigma P by epsilon 0. Sigma minus sigma P by epsilon 0. But what is sigma minus sigma P? It is again a ratio. Sigma minus sigma P is the ratio of sigma. Means suppose if sigma minus sigma P is 3, example. Not 3, maybe 12. If suppose, example, if sigma is 12, sigma minus sigma P is 3. Okay, then can we divide it now? Is it a multiple, right? K is a multiple, right? See, 12, that is what? 12, 3 will be equal to what? 12 by 4, can we write like this? 3 is equal to 12 by 4. Can we write like that? Are you understanding this? Sigma minus sigma P is sigma by K. It's a multiple. Sigma minus sigma P is a multiple of K. Okay? Is it clear?
Okay.
Okay.
Yeah, sir.
Now we'll directly go to V. What is V now? So I'm writing here V is equal to what? V is equal to ED. V is equal to sigma minus sigma 0 by epsilon 0 into D. Okay. Now what will happen? C is equal to Q by V. Okay. Implies C is equal to Q by sigma minus. Okay. So I will not write like this. This is sigma by K, right? Sigma by K. So this will become sigma is Q by V into K into epsilon 0. And this is also A will come here. Sigma is equal to Q by, I will write here once again. Q is as it is, V is sigma by K epsilon 0 into D. So it will become C is equal to Q into K epsilon 0 by, this is Q by A again, Q by A into D. So Q and Q will go away. C is equal to what? K into epsilon 0 A by D. So instead of writing like this, we write C is equal to K C naught. Means if we just multiply this one. So once again, see here, C is equal to Q by V. But what is V? V is equal to sigma K epsilon 0 into D. Now what is sigma? Q by A. Okay, divide it, cross multiply, you will get this value. So what is that? Epsilon naught A by D is C naught. So C is equal to K into C naught. Means what? K is equal to C into K, C is equal to K into C naught. Means what? It is the capacity of the capacitor is multiple of dielectric constant. K is what? K is the dielectric constant. What is the dielectric constant? Example here, K is dielectric constant. The value, maybe it can be mica or it can be glass. K is the dielectric constant, it can be mica or it can be glass. Is that clear? All of you?
Yeah, sir.
So can you explain once again?
From where, sir?
So this last part.
See here, it is sigma minus sigma P is the ratio of, or it is a ratio of the actual surface charge density, maybe divided by some constant. Now we have V is equal to what? V is equal to ED. But what is E? E is this one, sigma by K into D. Now C is equal to Q by V. So in the place of P, substitute the whole thing. And what is sigma? Sigma is Q by A. Simplify that, you will get K into sigma epsilon 0 A by D. That epsilon 0 A by D can be written as C naught. So C is equal to K into C naught. Clear?
Yes, sir.
Okay. Please. Now here what will happen if there are two capacitors connected in series, one after the other like this. Capacitors are connected one after the other. This is one is C1, C2 and C3. C1, C2, C3. This is what? Minus Q plus Q. Then minus Q, then plus Q. Then minus Q, then plus Q. Okay. So what will happen here? All the charges are negative. This is all negative and this is all positive. So what will happen here? So we have the voltage. We are adding the voltages. Okay. Suppose if it is connected like this to a battery, this is plus minus voltage, and this voltage here is V1, is V2 potential here, or potential difference is V1, V2. So we have the formula V is equal to V1 plus V2 plus V3. We have the formula C is equal to Q by V. Implies C1 is equal to, same charge will flow. C1 is equal to Q by V1. So V1 is equal to C1 into Q. Similarly, V2 is equal to C2 into Q. And V3 is equal to C3 into Q. And we have the formula V is equal to C into Q. So CQ is equal to what? C1Q plus C2Q plus C3Q. So that is CQ is equal to what? Q into C1 plus C2 plus C3. So this and this will go away. Formula is what? C is equal to C1 plus C2 plus C3. This is the formula for capacity of the capacitor when they are in series.
Again, sir, for series, isn't it 1 by C is equal to
Oh,
1
sorry,
by
sorry.
C1
This I went
plus
for
1 by
parallel.
C2 plus 1 by C3?
One second. Where did I make mistake? One second.
So you took V is constant. Actually,
No.
Q is
Voltage is,
constant.
no, I did not take voltage as constant. Charge I have taken constant, but I made some mistakes here. Wait 1 second. So here I made mistake. V1 is equal to, here. Wait. V1 is equal to Q by C1, sorry. V2 is equal to Q by C2. V3 is equal to Q by C3. This is the way we have it. So V is equal to what? V1 plus V2 plus Q.
V1 plus V2 plus V3.
Oh, so Q by V is equal to what? Q by V1 plus Q by V2 plus Q by V3. So what will happen now? So if you take common 1 by
No, sir, to C.
no, I have to
C1
take
to
C, right?
C3.
C1 is equal to Q by V1. My mistake, okay. So V1 is equal to V is equal to
Q by C1.
Q by C is equal to Q by C1 plus Q by C2 plus Q by C3. Okay, C3. So 1 by C is equal to what? 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula. Okay, clear? This is for series.
Yes, sir.
Now I will go for parallel also. So for parallel, the formula is what? Like suppose now the capacitor here is C1, C2 and C3. Voltage is V and V. Okay. Now charge here is what? Q1, Q2, Q3. So the formula is what? Total charge is equal to what? Q1 plus Q2 plus Q3. Voltage is same. So Q1 is equal to C1V, Q2 is equal to C2V, Q3 is equal to C3V. So Q is equal to what? So we can write here CV is equal to C1V plus C2V plus C3V. So C is equal to C1 plus C2 plus C3. This is the formula for capacitance. Okay, in parallel. Energy stored in the capacitor, just writing the three formulas. Energy stored in the capacitor. U is equal to half CV square, half Q into V. Half CV square, half Q into V. Plus Q square by 2C is equal to Q square by 2C. These are the three formulas for energy. Energy density means what? Energy per unit volume. Energy density small u is equal to energy per unit volume. Okay, energy per unit volume. Or we can also write capital U by V. Here also we can write capital U. So that is what small energy density is. Formula is half E into epsilon 0 AD. Half epsilon 0 E into AD. This is the formula for energy density. Sorry, energy density.
E
is
square,
only-
right?
No, this will not come. Volume will go away.
So E square, right?
In 1 second. Yeah, E square. Yeah. Energy density is energy per unit volume. Okay. So this completes your chapter. The next chapter will be current electricity. So in current electricity, drift velocity is very important. There are 3 derivations in drift velocity that we have to do. Then we have Wheatstone pitch and Kirchhoff laws. Those 3 topics are very, very important. And there can be a case study from current electricity, no doubt about it. Clear? So we'll see that. So these 3 lessons carry 18 marks. So focus more on these topics, okay? So automatically, if you read this one, 18 plus 18 becomes 36, I think. Optics, ray optics, wave optics, electromagnetic waves. Those 3 lessons are 17 or 18. Almost all these 2 modules carry 35 marks. Means half of the marks you will get from these 2. Clear? Yeah. Did you
Yes,
start
sir.
solving the past papers which I sent you? Did you do?